Okay, so we're doing the using logic to analyze the data exercise. That's part of week 1, dealing with data. So if you open up your REPL portal for this exercise, you'll find that you have 2 preloaded files. One is a main.py file, which contains your preloaded code, including all the functions that you're going to be asked to modify in the problem statement, as well as a .dat file, which contains all the data that we want to be filtering through our program. So if you read the problem statement in bold, you'll find the objective for this exercise, which, as stated here, you need to complete 4 functions, and each of these functions takes in a list of data points, which is the data that's contained in the .dat file here, and each of them does something unique to the data set. So the first function set is called numbers less than, and it should return the number of data points that are less than or equal to a. And a here is the data point that we want to assess with regards to each of the other data points. This is the data point that we want to filter our data set based upon. So each of the conditions that we write in our functions is based on the value of a. So with that in mind, we should start writing our functions. So first one, numbers less than, return the number of data points that are less than or equal to a. So when I hear number of things, I immediately begin initializing a count variable with a value of 0. And then I start a for loop, for I in range whatever the data set that I'm considering. In this case, it's y. Bear in mind that here y just is just a parameter. It's just a placeholder for now, and it's when you actually call the function, it's just fed the value of x here, and x is just an importation of all of these data points into this one variable. Just makes it easier so you don't have to keep going to the actual data file itself. So for I in range length of the data set, we need to check some condition, and that condition here is whether or not the current data value, or the current data point actually, that I'm looking at right now is less than or equal to a. So if the current value is less than or equal to a, or in other words, the ith index in the list that's called y, if that is less than or equal to a, then I want to count this data point. This data point matches the condition, and so I want to regard it as such. Okay, then whenever you write variables in a function, you want to return them. So return count. So that's the first function done. Second function does something similar, but instead of returning the actual number of data points, it wants the fraction of data points that conform to whatever condition that we want to impose. So do the same thing. We want to count something, so initialize count is 0, and then for I in range length y, we want to check the following condition. The condition we want to check is whether or not the current data point is bigger than or equal to a. So if the current data point in our list is bigger than or equal to a, then it meets our condition and we want to regard it as such. So we add it to our count variable. The function wants us to return but it doesn't want us to return the number of data points. It wants to return the fraction of data points that conform to the condition, and that we can express as count, which is the number of data points that conform to the condition, over length of y, which is the total number of data points in our data set. Okay, so that's done. Okay. Third function, percentage between. It should return the percentage of data points that are between A and B, where A is smaller than B. Okay, so we have an upper bound and a lower bound, and we want to return the percentage from our data set that conforms to that condition. So again, we want to count the number of data points that conform, and we do that by initializing a count variable, iterating through the actual list, and then with each iteration we want to check if the current data set, the current data point is, the condition is between A and B, where A is smaller than B. So if it's the current data point is bigger than A, which is the lower bound, and the current data point is smaller than B, which is the upper bound. And if so, if it meets both of these conditions, we want to count them. So we add them to our count variable. And once we've counted them all up, we don't want to return the count, the number of data points. Neither do we want to return the fraction. This function wants us to return the percentage. But since we have the fraction, because we've defined it in our fraction more than function, we can use the fraction, multiply by 100 to get the percentage. So that's third function done. Now the fourth function is simply the negation of the third. So while the third function, percentage between, wants us to find the percentage of data points that is within some interval, we want in the fourth function, percentage outside, we want to return the percentage of data points that is outside this interval. So the way we negate, we should have learned in other modules how to negate and conditions. So if you have A and B, the way you negate that is not A or not B. So negation of conjunction is negative disjunction. So, but the way we count these data points is very similar to the other functions that we've done. We initialize a count variable, we loop through the data set, and then once we've done that, the condition we want to check is if we're going to call this condition here A and this condition here B. So if A and B is negated by if not A, which is to say that current data point is less than or equal to A, or we want to negate B now, or current data point is bigger than or equal to B. And this is a direct negation of this here. Okay, and so now if our current data point meets these two conditions, we want to count it. Include it in our count variable by incrementing, and then Once we've done that, we return not count, not a fraction, but a percentage, like how we did with percentage between. So once we've done that, run our code, and it gives us the following terminal message. We should test it to check whether it meets the conditions set by the tests, and it does. Okay, and you submit, check the tests one final time, and it checks out.